Today's practical is on temperature changes, which is one of the required practicals for GCSE chemistry. In this practical, we will be looking at temperature changes in an exothermic reaction through the neutralization reaction between sodium hydroxide and hydrochloric acid. Reactions can be exothermic and endothermic. In exothermic reactions, the energy produced is released to the surroundings. And in an endothermic reaction, energy is absorbed from the surroundings. Now, the objective of this practical is to investigate the variables that affect temperature changes in a chemical reaction. The balanced chemical formula for this reaction is sodium hydroxide plus hydrochloric acid, giving you sodium chloride and water. Now, to investigate this, we are going to add increasing volumes of sodium hydroxide to hydrochloric acid and measure the maximum temperature reached in the reaction. So our hypothesis is that since this is an exothermic reaction, heat will be released, therefore the temperature in the solution should increase. The independent variable in this practical is the volume of sodium hydroxide added. The dependent variable is the temperature change, and the control variables in this practical will be the volume of hydrochloric acid and the concentrations of sodium hydroxide and hydrochloric acid. Before we start, we need to do a risk assessment for the practical. We are using glass equipment, so we need to handle them with care to avoid breakages. And also we are using chemicals such as hydrochloric acid and sodium hydroxide. So safety goggles should be worn throughout the whole practical to protect our eyes. Now, for this practical, we will need a 100 centimeter cubed measuring cylinder, a polystyrene cup with a lid, a beaker, a thermometer, a 10 centimeter cubed measuring cylinder, and a dropper pipette. And we will need 30 centimeter cubes of hydrochloric acid and 40 centimeter cubes of sodium hydroxide. Now, to start the practical, we need to place the polystyrene cup into the beaker to prevent it from rolling over when we add the solutions to it. Next, we need to take the lid and insert the thermometer through the hole like this, and then place the lid on top of the cup. We need to adjust the thermometer so that the bulb of the thermometer touches the bottom of the cup. Secondly, we need to measure out 30 centimeter cubes of hydrochloric acid, which I have already done. We need to now pour this into the polystyrene cup. So I shall now remove the lid, holding on to the thermometer at the same time, and pour the hydrochloric acid in. Now, I will take the reading on the thermometer and record this reading as the initial temperature of the hydrochloric acid on 0 amounts of sodium hydroxide added. And I read that at 22 degrees Celsius. Now, we need to measure out 5 centimeter cubes of sodium hydroxide. And I shall measure that using the small measuring cylinder. and I should use a dropper pipette to ensure accuracy. Remember to read at the bottom of the meniscus. Okay, that's fine. Now, I need to add in the sodium hydroxide to the hydrochloric acid. But remember that as soon as we add the sodium hydroxide in, we need to replace the lid immediately to minimize any heat loss. And also, the reason why I'm using a polystyrene cup in this practical is because it's a thermal insulator, and therefore we can minimize the heat loss from the surroundings and from the bottom, and by using the lid we can minimize the heat loss from the top, because the heat loss will then affect the maximum temperature reached. So in that goes. I shall now just gently stir with the thermometer to evenly distribute the heat energy throughout the solution. Now we need to observe the thermometer and record the temperature when it stops changing. This temperature should be recorded as the maximum temperature reached on addition of 5 centimeter cubes of sodium hydroxide solution. Now, we need to repeat this step for a second trial so that we can obtain results to work out a mean value. And we calculate mean value so that we can get accurate and reliable results. The maximum temperature reached on each addition of sodium hydroxide should be recorded in a results table, and also the mean values should be recorded in the table. Our results show that as we increase the volume of sodium hydroxide solution, the maximum temperature reached increases. This is because when we increase the volume of sodium hydroxide, we increase the number of particles of sodium hydroxide, which then react with hydrochloric acid more readily. Also, our results show that the optimum temperature reached is 32 degrees Celsius on adding a volume of 30 centimeter cubes of sodium hydroxide. However, at a volume of 35 centimeter cubes of sodium hydroxide solution, the maximum temperature reached starts to decrease. This is due to the fact that we've added so much sodium hydroxide that there isn't enough hydrochloric acid to react with it, leaving some unreacted. We can also plot a graph with the volume of sodium hydroxide solution on the x-axis and the mean maximum temperature change on the y-axis for each volume of sodium hydroxide added. Draw two straight lines of best fit.